All right, here we go. Page 1 of practice test for types of reactions. So the first question says for you to identify what each type of reaction is. This is just, there's no elements or compounds, but as you can see, what they're doing here is they're taking A or B as single elements, right? And then when they combine them, they form a compound couple. So this should help you in your mind just sort of understand that elements, are like single people, compounds are like couples, and A or B or X or Y down here, those are just simply either elements or they're going to be polyatomic ions, okay? And when you actually put those in, all of the, well, this is 4 of the 5 types of reactions will follow that basic sort of formatting, okay? So number 1, you can clearly see those are 2 single people becoming a couple compound. So that's single replacement. That's going to be D. Oh, whoops, sorry. That's going to be direct combination, B. It's hard to do both video and do this at the same time. Bear with me. I'm trying to get to see this at the same time. Okay. Second one, we have got we have a single person and then a compound couple. The single person is kicking out B. A kicks out B, forms AX, which is a compound couple plus single person. So that is a single replacement. That's the one that I was trying to do the first time. All right, 3. AX plus BY forms AY plus BX. You can see that those are 2 compound couples. They are double displacement, switching partners. And so that one ends up being double replacement reaction. So that is C. 4. AB forms A plus B. You can see that you've got a compound couple that's actually breaking up into single elements. And so you've got decomposition, A. All right, 5 through 8. Describe the following types of reactions. I think that you guys can just use your notes. Use lecture notes. We're not gonna have too much time for that, so keeping the video short. All right, decide whether each of the following equation represents a direct combination, decomposition, single replacement, double replacement, direct reaction, or double replacement reaction. Write your answer on the line. Okay, it's the same thing as up here, but now you see they're just actually using chemical formulas. So if you want, you can go back up here and see the simple pattern format, or you can use your lecture notes. That's up to you. So the answer is you've got a compound couple breaking up into single elements. So that ends up being a decomposition. So that is, what are they using? Decomposition D. Let's see, the next one has 2 compound couples. You can see they're switching partners, and so that one's ends up being a double replacement. They're using DR for that. Next one is 2 single elements becoming a compound couple. So that one is direct combination. So that is DC. Also, direct combination could be called synthesis. And so if you maybe were confused on that, yes, you can call it synthesis. Same with single replacement, could be called single displacement. And double replacement can be called double displacement. So that's, all acceptable. This next one, you've got 2 compound couples. You see they switch partners, form 2 new compound couples. And noticing when they switch that they're using their charges. So that's why over here it's OH with a polyatomic ion, and you see over here they've got a parentheses, which in my opinion, I would say do that all the time over here so you don't get confused. For your polyatomic ions in the front of your notebook, and they have a 2 because basically that's barium 2+, that's a minus, and so you need 2 of those to balance And let's see, 1 to 1, that was a plus, that was a minus. And that one was a negative for chlorine. Barium was a 2+. When you recombined it over here, though, remember, don't take the baggage. Barium is not having a 2 down here because it's not needed. So, wait, let me see here. Chlorine, sorry, is not having a 2 down here. Sorry, it's really hard to video and do at the same time. Just bear with me. Anyways, 2 down here is not taken over for taking the baggage. So we're doing 2 negative ones to balance the 2+ here. But over here, this is a negative and that's a positive. So you don't need 2. So that's what I mean by don't take your baggage into the next compound couple. Okay, I'm diverging, but I just saw that polyatomic ion and I knew you guys would be like, why is it here and not here with parentheses? So I just wanted to explain. Anyways, that is a double replacement. So that is a DR, double replacement. Next one, I'm just gonna go quicker on these here. Single element, compound couple, swap out. So this one's gonna try to kick out copper. You have to go to your activity series, which by the way, that is over here in your notes right here. So activity series will say hottest on top. This is the positive ions here. This is the negative ions here for the column. Hottest will kick out anything below it. Lower cannot kick out anything on top, okay? Remember that, going back. So they already did all that looking up and they said, yeah, this is gonna happen. Zinc will kick out copper. So now it's zinc sulfate with copper all by himself. So that's a single replacement, SR. Next one, we've got a compound couple that's breaking up into 2 single elements. So that is a decomposition, which is D for them. This is single replacement. The magnesium is going to kick out the lead. Again, they've used the activity series already and figured it's going to happen. So we're going to have single replacement, SR. Okay, the other thing I do want to point out to you before moving on, I'm going to pause this so that I can get smaller videos. Noticing the H2, N2, F2 of ice cold Br2. These are the 7 diatomic elements that can never be written by themselves. You have to roll through those in your brain whenever you're doing any reaction writing like they're doing here. Notice they did that. So you'll look and you'll notice that when you have a single element like O, it was one of the 7. So you never write it as O by itself, it's O2. Where else do we see that? Here, chlorine. Over there, they didn't write Cl by itself. Notice it was okay to write C by itself. It was okay to write S by itself because it's not on the 7 diatomics. Moving through, not zinc, copper's not on, carbon's not on, lead and magnesium's not on, hydrogen is, and so you see the 2 over here. Also, they have gone through and balanced. So that's what these whole number coefficients like 2, 2, 2 are all about. It's just making sure that the number of each element or polyatomic ion type that's on the left of the arrow is equal to the number on the right. We don't balance by putting subscripts in. Subscript, sub, below, those things are only there to balance charges out, like what I tried to show you up here really quick, okay? That's a quick refresher. I'm going to pause this video and move on to the next chunk.